Let me record. Okay, great. So first and foremost, I'd like to thank everyone for coming. Okay, it's my first time actually doing something like this, and it's an initiative that I started a few months ago. And I'm actually very happy that quite a large number of students are actually pretty interested in this thing that I started. So hence why I decided to start this little online session as well, free of charge for everyone. Okay, so meanwhile, let me start off with a little bit of slides and some introductions to myself first. Okay, so let me introduce who am I. Okay, so my name is Kaiwen. Okay, I'm the specialist tutor for Overmarks A Math and E Math. So I teach math like in general. I've been teaching for about 5 years already, and currently right now I do have. Oh, am I muted? I'm not, right? Yeah. I have two accounts. So one of it is talking. The face cam is not talking, so you should still be able to hear me. Okay, yeah, I'm not muted. Yeah. Okay, can I just verify that I'm not muted, right? Am I muted or anything? No, right? Okay, thank you so much. Okay, yeah, I'm not muted. Thanks. Okay, so yeah, let me carry on. Okay, so I've been teaching for about 5 years already, and I have group classes. So I primarily teach group classes now. I do not take in private students at the moment because I'm pretty busy with school. So if anyone's interested to join my group classes, you are feel free to look for me. Whatever level you are, you can just look for me as well. So I do teach past secondary school as well. So I do teach junior college level, if there's anyone here that's interested, of course. So yeah, if anyone's interested, you can look for me. Now, just a little bit of background of myself, just to like give like some kind of validity of my own education level and everything. Currently, I'm in NTU. Okay, so I'm studying in my third year. I just started my third year last week. Okay, and I'm studying mathematics in NTU. Okay, so I'm one of those weird people that love to study math. So yeah, I'm one of those like weird kids that really hardcore love math, which I don't know whether any of you can relate to it, but if there are, uh great to hear that. Okay, so I love geometry a lot, and I do topology. I study abstract topology. I'm studying like knots and surfaces right now. A lot of very interesting stuff that is up my alley lah. Okay, so if anyone is interested to have a conversation with me with regards to this kind of stuff, feel free to hit me up and I can entertain you as well. Okay, so yes, thank you very much for the number of people joining. Okay, so I'm just having my introduction right now. Okay, before I begin. Now, okay, these slides are actually from my crash course. So I just conducted my second crash course 2 days ago. So I do recognize some names here from like 2 days ago. So hello to you guys. Great that you guys like my session to be able to join me today again. But yeah, I'm sharing my slides one more time. So I'm doing this exam countdown for everyone right now, as the O levels are already coming. So this is, I believe majority of you are express students. So currently there's about 63 more days to the paper for paper 1 and about 66 more days to paper 2. After that, about end
still so long, power lah.
Too bad lah. Okay, so if let's say after that, then you get to relax all the way until your further education lah. Okay, so just take this time, study hard, and then after that you get to play for the rest of the 2 months. Okay, now let's cover a little bit about the syllabus. Okay, so I think this is something everyone already knows. So these are all the topics, okay, in the syllabus, barring vectors, because vectors has been taken out of the CLT because of the CLT and COVID. Okay, so I say good job for everyone, but please be careful, okay, that vectors is a very heavy topic in A levels, okay, or in post-uni, post-secondary school education. So I suggest don't throw away those knowledge. Do keep it in your bank if possible. Okay, now I do know that some students here, okay, you guys should have listened to my podcast, and you guys did hear about my topics that I feel that are a little bit more challenging in the EMAth syllabus. For example, algebra. Some people are very weak in algebra. We have matrices. Some people are weak at that. Properties and circles. This one of the major topics out there. Okay, trigo, coordinate geom, and vectors. Okay, these are some of the more highly requested topics out there for notes and for a little bit of help. Okay, so I will be focusing, not say a lot of time, but a little bit of time more on these topics to give you guys a little bit of hints and tips and tricks lah, of course. But of course, if you want to hear more from me, because I cannot share so much within 1 hour, you can feel free to sign up for my crash course, and you can feel free to look for me for help as well. Okay, so yeah, okay, before I move on to the exam tips and strategies, I want to actually start the content first. Okay, then let me cover the topics and all the questions that I've set. Okay, now it is impossible for me to actually cover every single question, because what I did was that I made about at least 5 to 6 questions per topic. So it is impossible for me to cover it within an hour. So what I've done is that I've actually selected some of the more challenging questions, and I've also based it off like my students doing the paper and like people submitting your works to me, okay, and seen where are all the careless mistakes, where are all the common mistakes, and I decided to go through like at least 1 to 2 per topic. So if let's say in the event you wanted me to go through a certain question, but I couldn't cover it today, you can always PM me and I can always explain them to you via writing on my tablet and everything. Okay, so this session is more for like the general public and for everyone that is interested to learn a little bit more about the topic. Okay, so without further ado, okay, I hope you guys enjoy the session while you hear me talk for the next 1 hour. Okay, if you have any questions, same thing. Can I share the slides? Okay, yes, I can. Okay, if you want to PM me, if possible, please PM my sharing screen account, because that is the one that I'm currently looking at. Because I'm using a desktop, so I don't have a face cam. So my face cam is just to show my face so that I don't feel like I'm talking to no one. So yes, I can share the slides. I'm totally fine with that. So yeah, if I forget, someone should remind me. Okay, if not, let me begin. Now, the solutions have already been put up for the month of July. So if let's say you're interested in reading the solutions yourself, you can do so as well. Okay, and the questions are already up there for the past 1 month already. So if you've been attempting the questions and you feel that the questions are pretty tough, I do say sorry, because yes, the questions are a little bit on the more difficult side. That's how I chose the questions anyways. Okay, so I decided to choose a little bit more challenging questions, but still manageable and within the syllabus as well. Okay, so without further ado, let's begin with the first chapter, numbers and numbers and their operations. Okay, so this is the document that I prepared every month. Okay, so and I start the questions like this. Now I receive feedback that students do want to know the number of marks per question. So unfortunately, I didn't manage to do it for the month of August. I did it for the A math, but I didn't have time to finish it for the E math. So for the month of, what's after August? September, yes, I will be doing it. Okay, so I'll put the number of marks per question so that you guys get to have a rough estimation as to how much each question is worth. Okay, if not, let's begin with the first question that I wish to go through, which is question 1. Okay, which is this one right here from Victoria School. So if you see your, okay, what's this? Request for live transcription to be enabled for the meeting. I've never used it before, but sure. Okay, so yeah, if you see some transcriptions on the screen, then great, because I've never used that feature before. Okay, great. So I'll start with the first question, which is the one here. Evaluate the following without the use of a calculator. Now, this question actually came out in my curator notes. So I'm actually going to refer a little bit to the notes that I prepared as well. So if you're interested, you can just take a look at the notes that I've prepared here. Okay, so this is the question that I'll be tackling today. So if those that have bought my notes, you jump to the question at the back here. Let me find the question. Yes, this one. Okay, it's pretty similar. Okay, in terms of concept, what we're trying to do, and it's also from the same school. So I think these kind of questions are pretty unique and pretty interesting. So I love this question a lot. That's why I decided to set it as the opening question of my paper. Okay, and I think one thing really cool about this school is that they actually put out the marking scheme so that tutors like me can actually see what students wrote. And a lot of students actually wrote NA, okay, for this answer, because there are some jokers that actually go and type this whole sum into the calculator. So sometimes when you're very desperate, right, you will start typing random things into the calculator, and students actually type this in, and you actually get an NA, which is impossible. So, and then there are students that actually wrote down NA as their answers, which is a bit strange if this is an evaluation question. So how will you approach this question? Now, I'm going to be copying the question here. Okay, and once I begin, I won't stop anymore. Okay, so 3 to the power of, I hope you can see my handwriting. My handwriting is pretty neat. Okay, so I hope you guys can read my handwriting. Okay, 11003 minus 26 multiplied by 3 to the power of, 11,000. Okay, plus 1 divided by 3 to the power of 11,001, yeah, plus 3. Okay, so whenever you're facing a question like this, you should always look out for common factors and common things to take out in all the terms. Now, one common mistake that I've seen pretty recently was this. I'm going to write it here. Now, common mistakes doesn't mean that you laugh at the people that make those mistakes. It's just mistakes that people make, okay, and try to avoid them if possible. Now, what one person did was this: 3 to the power of 11003 minus 3 to the power of 11000 multiplied by 26 plus 1. Okay, so they move the, oh, it's laggy, is it? So sorry about that. Yeah, but I mean, it's fine on my systems because I'm streaming on both devices. So I hope it's fine. So sorry about that. Okay, so yeah. Okay, I'll talk a bit slower. I think that will help as well. Okay, so a common mistake was this: to actually move the 26 over and out of the number, which is completely wrong. Okay, so please just take note, okay, that this is not the right thing to do. Okay, because you cannot just pull out the number like this. The number 26 here is actually together with this 3 to the power of 11,003. Okay, so what we should actually do for this particular question is to pull out common factors. Okay, now we can see that there's 3 to the power of 11000, 3 to the power of 11000 as well, and 3 to the power of 11000 as well. So that's what we can actually pull out. Okay, so that's what I'm going to do. Now I'm going to split up the terms a little bit. So I'm going to do it as 3 to the power of 11000 plus 3 minus 26 multiplied by 3 to the power of 11000 plus 1 divided by 3 to the power of 11000 plus 1 plus 3. Okay, so what I've done here is by splitting all the terms up, okay, and what my goal is to fish out this particular term, which is what I'm going to do right now. Okay, so by indices law, we can actually split out the terms a little bit even more. 27, 3 to the power of 11000, okay, minus 26, 3 to the power of 11000 plus 1 divided by, oops, sorry, my handwriting, divided by 3 to the power of 11000 plus 1. Okay, so what I've done here is to isolate out 3 to the power of 11000, and that's my objective. Okay, so now this is imagine, okay, let's take, for example, maybe is to make things easy to see, I'm going to let x be 3 to the power of 11000. Okay, and what happens? You get 27x minus 26x plus 1 divided by 3x plus 1. Okay, you're going to get something like this, and let's simplify it even more. X plus 1 over 3x plus 1. The x plus 1s can cancel, and you get 1/3. Okay, so the final answer is 1/3. Now, this technique over here of using a substitution is very powerful because we always use substitutions when things get very complicated. Now, this is a technique that is used in A-Math as well, especially when your terms get super big or super complicated. It's a technique that I learned in university and also during my JC time as well. So I think this is a very useful tip right now. Like if you cannot see 3 to the power of 11000, you can always replace it with something simple. And with that, you get to reduce the value into something really small and easy to see. Okay, and this is the full solutions for this question. Now I'll be uploading this handwritten notes right here into the Telegram chat as well. So if let's say you want my handwritten notes or anything, you can feel free to take a look at it over there as well. Okay. Now, if you have any questions for me, you can just interrupt me and you can ask. If not, then I'll just carry on. Okay. Okay, let's move on. Now I have another question that I wanted to go through, which was this one. Question 3. This is the Dunyan Secondary School question. Okay, now written as a product of its prime factors 270 equals to 2 times 3 cubed times 5. Express 396 as a product of its prime factors. Okay, so this is a pretty simple question. So let me do it quickly. Now for part A, okay, 396. Okay, this will be equals to 2 squared times 3 square times 11. Okay, this can be done using, so is there a remaining x value you have to sub in? No, because the x values will magically disappear. Okay, so by doing it this way, you have cancelled the x value away. So the terms, you actually don't need to sub it in anymore. Okay, so that's for your question. For Song Tian, right? Sorry, Chi Song, sorry, I'm so sorry. The answer key for the attached, I'll give it out during the AMAth live stream. So I haven't prepared it yet. Sorry for not seeing your question. Okay, so let me carry on from here. Okay, so 396 equals to 2 square times 3 square times 11. Now you can use the ladder to solve, but personally, I don't use the ladder because to me, the ladder is a little bit slow. Okay, so if you want a quick way, I just use the calculator and don't even show any working. And it's totally fine with that. Okay. Part B. Now, I hope everyone has the question paper, so I don't need to move from paper to paper, okay? But never mind. Hence, find the smallest positive integer m such that 270m is a multiple of 396, okay? So what I'm going to do right here is I'm going to write out the value of 270 as well. Okay, and this is 2 times 3 cubed times 5. Now, the question is saying that we need it to be 27. Okay, let me label this as part 1. 270m is a multiple of 396. Okay, so what does this mean? It means that you must be able to find the values of 270m inside 396. Okay, so what I love to do, right, is this step. Okay, so I will usually do it this way. 2 square times 3 square times 11 divided by 2 times 3 cubed times 5 times m. Okay, so this will make it like a multiple. Okay, so I must be able to find every single element in the numerator inside the denominator. That is my goal. Okay, so right now I'm going to check term by term. Okay, so let's see. Denominator has a 2. But my numerator is a 2 square. This means I'm missing a 2. So that's why m starts off with a 2. Okay, same thing, repeat the process, 3 cubed. Okay, now let's check. I have a 3 square in the numerator. This means minimum must have a 3 square in the denominator. Okay, and there is already there. So I do not need to add in a 3. How about the 5? Okay, there's a 5 here, there's no 5 in the numerator. This means that the 5 is not important in this case. We can just ignore it. Okay, how about the 11? Now there's an 11 in the numerator, but I'm missing an 11 in the denominator. Since I'm missing, I'll just add it in. And that's why the answer is 22. Okay, by writing it in a fraction like this, it becomes very clear what numbers you need to take, what numbers you can ignore. Okay, so this little fraction here is pretty powerful. Okay, part 2. Now the question states that you need to find the smallest positive integer such that the cube root of 369n is a whole number. Okay, so this means what? Okay, let's write it out. Cube root of 396n is a whole number. Now, this question here can be rephrased a little bit. Okay, it can be rephrased into 396n is a perfect cube. Oops, sorry, my bad. Okay, and I think this is the one that most people will be able to actually most people will have seen this kind of questions before, rather than the whole number one. To respond to okay, your name is Hi, sorry. To respond to Hi, yes, look into the Overmark Telegram chat. You scroll up a little bit, it is there. Okay. So 396n is a perfect cube. Okay. So what this means, right, is that we need to make sure that the numbers inside here, all the powers, are divisible by 3. Okay, what's the reason why? Okay, blue means I'm writing content. Okay, cube root of a is the same thing as a to the power of 1/3. This means that all your powers must be divisible by 3. Okay. Okay, so yep. This is y, so that's why I'm going to do that right now. 396n equals to, what's 396? Sorry, 2 squared times 3 squared times 11. Oops. Okay, now my objective is to make sure that all the powers become divisible by 3. So I'm going to start checking right now. This is a 2, so I need to add an additional 2 to make it a power 3. So there's a 2. Same thing for the 3, same concept. 11, there's only 1 copy, so I need to add in 2 more copies. Okay, 11 squared. And this is the final answer, 726. Okay. Okay, to answer some questions in the chat, number 1, yes, to Amanda, yes, the recording will be available on YouTube, so you can look for the Overmark YouTube channel and the recording will be there. Next, for Jolene, can you repeat for part 1 why 5 is not included and 11 is included? Okay, so yes, n is 1 to 6, thanks. N is 7 to 6, correct. Okay, what's the reason why you include 5 and you do not include 11? You ignore 5 and include 11? Because your objective is to make sure you can find this black color box inside the denominator. So you must be able to find 2 square, 3 square, and 11 inside the 2 times 3 cubed times 5 times m. That's your objective. Okay, so since there is a 5 that is not inside the black color box, right? This means that you can ignore the 5. But there's an 11 there, so you need to put in the 11 into the denominator. So that, yeah, that's the reason why it must be included. Okay, next. For the fraction, how will you know which to put into the numerator and which to put into the denominator? Now, the general rule of thumb is this: all questions will be phrased in the exact same way. Okay, so something is a multiple of something. So the last digit is always in the numerator. The one with the constant is always in the denominator. Okay. Yeah. Okay, so let me move on, or else this session will take too long. Okay, so next question that I want to go through will be the next topic, ratio and proportion. Now, I actually do want to tackle only question 1. Okay, actually, yeah, I want to tackle question 1. Okay, now this is under the concept of map scales. Okay, so map scales is a pretty popular topic, okay, out there. So the fun fact for map scales is that there's only 5 different questions types out there for map scales. Okay, and if you want to see it, you can come into my notes. Okay, and I will actually summarize all 5 different question types of the map scales. Okay, and there are example questions as well. Okay, to prove every single type of questions out there. You just need to memorize what these 5 question types are. You can solve every single map scale questions out there. Okay, so let's do it together. A model of a school is made to a scale of 1:50. If the height of the school or in the model is 36, what is the actual height of the school in meters? Okay, so let's solve this question. Okay, maybe I'll split it up in pages so it's easier to see. Okay, so the question states that I have a linear scale, 1:50. Now, what does this mean? Okay, what does this mean? This means 1 centimeter on the map is 50 cm in real life. Okay, now remember map scales are always in centimeters, okay, and map scales do not have units in them, so you must be really careful. Okay, so this means this. Now the question states that the model is 36 cm, so therefore the real life, wait, hang on, yeah, correct, real life, okay, is equals to 36 multiplied by 50, okay, which is equals to 1800 cm in meters, 18 meters. Okay, and this is the answer for this question. Okay, this for part A. Now for part B, okay, the question states that the actual floor area of the school is 700 meters square. Find the corresponding floor area of the hall in the model in centimeters square. Now, whenever you're facing questions like this, excuse me, you need to actually convert between linear scale to area scale. Okay, so that's what I'm going to do now. 1 cm represents, let's do it in, let's see, 0.5 meters. Okay, now how do you convert from linear scale to area scale? We always square the values. Okay, so 1 cm square is to 0.25 meters. Okay, what's the reason why? If you remember into your Sec 2 geography, okay, there's the box thing, right? Then here, okay, I don't take geog, but this is what I remember, and students tell me I'm correct. So this is 1 cm by 1 cm. This is how we find our area. Something along these lines, this is why we square the value. Okay, I don't know whether this is 100% true, but this is what my students told me. Okay, so yeah. Now, so this will be 0.25 meters square. Now, the question states that the hall is 700 meters square. So this is the first tip for all of you that are here. Whenever the question asks you to find, they give you something, right? Always, sorry, yeah, meter square, I changed it already. So once the question gives you something, right, you always change that something into 1 first. So what I'm going to do here, I'm going to make 1 meter squared. Okay, and this is just 1 over 0.25. Okay, cm squared. I purposely force the thing that I want, which is 700 meters, into 1 first. Then you multiply 700. This will make the process so much easier. Okay, and the final answer is 2800 cm squared. Okay, and these are the 2 answers for map skills. Okay. Okay, great. Okay, now I won't be touching the other question. Okay, even though I know the other question is slightly trickier. Okay, but I want to save this question for next month's session. Okay, how do I get 1 over 0.25? Okay, you can think of it in terms of unitary ways. So it's just a very standard way of doing things. So whenever you want to convert like this kind of values into 1, you just divide over. Yeah, it's just a process. Okay, so for example, 0.25 meters square is to 1 cm square, right? Okay, if you want to see it mathematically, this is 1 over 4 meters square. Okay. 1 over 0.25 is 4. Okay, so you're just dividing it over by 1. Okay, this is the reason why. Okay, so yep, let's move on to the next topic. Okay, so for this one, let's see, which question did I wanted to go through? If I remember correctly, it's question 1 for percentage. Yes. Okay, as we go through the questions, right, I will tell you which questions are slightly tougher, but unfortunately for those kind of questions, I may not have the time to go through. So I'll just let you know that the questions are a little bit more challenging. So do refer to my solutions for the full answers for it. For part A is usually quite tough, so you can just go and take a look at it. Okay, for this one, this month's questions, question A is pretty difficult. So just take some time to review the solutions for part A. Okay, because a lot of people couldn't do part A. Okay. Now, the radius of a circle is increased. I'll be going through this. Now, the radius of a circle is increased by 10%. Express the original circumference as the fraction of the simplest form of the increased circumference. Okay, so this is why the reason why I chose this question is because I wanted to explain to you guys what is the definition of increased by 10%. Okay, because right, some people have this misconception of increase by 10%. Okay, so whenever you're increasing something by 10%, you must be really careful of how this terminology is being used. Okay, so the radius has increased by 10%. What does this mean? It means that R has changed to 1.1 R. Okay, because there is 100% as the base, plus an additional 10%. Some people actually do think that it is 0.1 R, which is incorrect. Okay, so this one is a common mistake to make, so please do not make such mistakes. Okay, now the question is saying that you need to express the original circumference. Okay, so let's write the ratio out. The original circumference, 2 pi R, over the increased circumference, so 2 pi 1.1 R. Final answer is 10/11. Okay, now remember ratios is not always in this form. It can always be written as A/B. Okay. Now for part B, the question is asking for the percentage increase. Okay, so percentage increase, what is the formula? Final minus initial over initial times 100%. Okay, so let me write that down. Final minus initial divided by initial times 100%. Okay, so this is the value that we are interested in. So what is the final value? Now we're talking about area. So this is pi 1.1 r square minus pi r square divided by pi r square multiplied by 100%. Where you will see that all the r squares and the pi's will vanish. Okay, and the answer is 21%. Okay. Okay, these are the answers for the percentage questions. Now, usually I don't focus too heavily on the percentage or the beginning few questions because they are pretty simple. Okay, only for the more difficult topics at the back, then I'll move into it. Okay, move a little bit more into them. Okay, now let's look at the next question. Okay, which is rate and speed. Okay. So I hope everything is fine so far. If you have any questions for me, you can unmute yourself or you can just ask me in the chat. Remember, please ask my screen share account. Do not ask my face cam. My face cam is just for me to show my face. That's all. Okay. Now, for rate and speed, this is a very common topic that a lot of students cannot do well. So that's why I've decided to go through one of the questions here today. And I want to go through question 1. Okay. Now, this question 1 is a very typical exam question. So I have students that took their prelims today and they couldn't do this kind of question. So I wanted to go through this question. Okay. Now, the diagram above shows a speed time graph of a journey. Find the speed after 25 seconds. Okay. So how do you actually find the speed at a certain point? Okay. Now, this is all got to do with ratio. Okay. So there is a certain ratio that we can write out here. Let me write it for you guys. Okay, so for part A, okay, what is the ratio? To find the speed, okay, we have the speed that we're looking for. Let's call this speed divided by 25. Okay, divided by the 25 seconds equals to 60/40. Okay, it's a form of a ratio such that you are able to find, because the triangle is proportional, the time is proportional to the speed. That's why you can use this relationship to find the speed. So speed is equals to the 37.5 meters per second. Okay, this is the answer for part A. Now for part B, the question is asking you for the total distance traveled. Okay, remember there is this, yes, you can use the y equals to mx plus c to solve the question as well. Yes, correct. Okay, there are many ways of solving this question. You can actually solve for the gradient of the line and then go and substitute as well. So we can only do this method when the graph passes through the origin. Yes, correct. For most speed time graphs, you'll always, okay, actually for every single speed time graph, you will always pass through the origin because it is not possible for an object to start from a certain speed. In your level, always start from 0. So you can always use this method. Okay. There's another way to doing it is to equate the gradient. Okay, so you can actually find the gradient of the line first, then use that coordinate to actually search for the gradient as well. Okay, please do not annotate on my thing, please. Thank you, if you don't mind. Thank you. Hang on, how to disable that? Yeah, there you go. Okay. Okay. So for part B, okay, the question is asking you for the total distance traveled. Okay, so let's do that. Now, there is this diagram that I love to draw for students. Okay, so let me draw it out for you guys. DSA. Okay, it's not direct school admission. It's distance, speed, and acceleration. If you're given a distance time graph, you want to find the speed, you're looking for the gradient. If you want to find the speed, if you're given a speed time graph, you want to find the acceleration, look for the gradient. If you're given an acceleration time graph, you want to find the speed, look for the area. If you're given a speed time graph, want to find distance, find area. Okay, and this diagram, if you want it in a beautiful way, looks like this. Okay, if you're interested, you can take a screenshot of this. Okay, because this is a pretty important diagram. So let me re-explain the diagram one more time. If you're given a distance time graph, want to find speed, use gradient. If you're given a speed time graph, want to find acceleration, use gradient. If you're given an acceleration time graph, want to find speed, use area. If you're given a speed time graph, want to find distance, use area. Okay, this is a very this is also to remember kinematics. Yes, correct. This diagram is also used in kinematics as well. Okay, so this is a very powerful diagram that you can use to convert between your integration and differentiation for kinematics. Okay, and this one I will cover it on Thursday, which is my A-math session. Okay. So for this question, since you are looking for the distance and we are given a speed, we are looking for the area under the graph. Okay. So this is a trapezium, or this is a triangle plus a rectangle. So area, area is equals to half times 40 times 60 plus half, oops, sorry, not half. Rectangle would be 60 multiplied by 100 minus 40. Total answer is 4,800 meters. Okay, this is part B's answer. Okay, I think for my future sessions, I will actually prepare the document with some space under the question such that I don't need to jump between papers. But as of right now, this is my first time doing it, so I'll remember to do it in the future. Okay, so this is the last thing I want to go through for this question, which is sorry. Thank you for that. Yeah, I hope it's better. Yeah. Okay, on the axis below, sketch the corresponding distance time graph for the journey. Okay, so this is the one that I want to focus a little bit on, okay, which is the sketching, the conversions between a speed time graph to a distance time graph. Okay, so usually students have a little bit of challenge with this. So let me go through it a little bit slower. Okay, so the graph looks something like this. Okay, aggregation. Okay, and this is the graph that I'm interested in. Okay, so this is the speed, time, distance, time. Okay, so let's start the explanation. Now, when you're looking for the speed time, when you're given a speed time graph, you need to find the distance time graph. Remember, you're looking for the area under the curve. Okay, so what you're going to do is you're going to observe what happens at the respective areas. So let's say, for example, we start from here. Now, I usually will split the triangle into multiple rectangles. Okay, so it's something like this. And then you ask yourself, these rectangles are actually increasing in area. Okay, so what we can actually do, or what we can actually see from here, is that the area under the graph is increasing. Okay, the area under the graph here is increasing. Okay, so hang on now. Okay, so that's why. Okay, sorry, it's a bit ugly, but yeah, the area under the graph is increasing. So therefore, this is an increasing gradient graph. Okay, so therefore, it will look something like this. It's a curve. Okay, so it's a curve. Okay, it shouldn't be a straight line. It must be a curve. Okay, I'll answer your question in a while. Okay, so the next one is about this rectangle here. Now, same thing, I'm going to split it up into rectangles. Okay, what do you notice about the rectangles? Is it possible for us to buy the notes? Yes, it is. So later I'll talk a bit about it. Okay, you can go to the Overmark website to actually look for my notes. Okay, yeah. So yes, so sorry for breaking my train of thought. Yeah, okay, so you can actually increase the, sorry, not increase, sorry. Yes, to actually find what is the area under the graph for the rectangle, okay, what you will realize is that the area is consistently increasing. So it is still increasing, but it's consistently increasing. Okay, so that's why for here, this is a straight line going up. Okay, remember, this is a curve, and this is a line. Okay, And this is how the values look like for this question. Okay, now just to show you my notes, okay, there are example questions and I've sketched every single possible curve out there in the syllabus. So you can refer to what point A refers to what point B is, what point D is, what point C is, and how do you do the relevant conversions in the question. Okay, it's the same thing here. And I've done it for the speed time graph as well. Okay, and I have example questions to teach you how to do the conversions. So for example, this question here, I actually write down the step-by-step processes as to how to understand why is it like when you're converting from speed to distance, the graph looks like this, it looks like this, it looks like this. Yes, you do need to include the distances as well. Apologies for not doing that. So thank you for asking that question. This is 1200 and this is 4800. Thank you for the question. Okay, so yes, to answer, actually you guys don't need to directly PM me. You can just blast it to everyone so everyone can read as well. Okay, so it's a learning experience for everyone. Okay, anyways, I want to know why we cannot use S times T when finding distance in a speed time graph, but we have to find area under the graph. For speed times time, right, you're doing S times T, right? S times T is literally finding area under the graph, because you're taking the S value, multiplying the T value, which is finding the area of a rectangle. So you have essentially just found the area under the graph. Okay, so I hope I answered your question. Okay. Okay, in a trapezium. Okay, so that's why for trapeziums, the formula is not S times T, ma. Okay, that's why the way to find area under the graph is not S times T. Yeah, it doesn't make sense. Okay, because, and your speed is not constant. Yeah, if you want to use S times T, right, the condition is that your S must be constant. But for this case, it is not. Okay. Okay, I need to move on. Okay, so next topic. Okay, yes, now, okay, there are some questions here that are pretty good. Okay, so I would like to point out some of the questions that I feel that is good practice. Okay, so number one, I will go through question one because I know there are people's algebra is not strong. Okay, and the next question I want to go through is question, I cannot remember which one, shoot. The number pattern question, this one. Okay, so for those that haven't realized yet, this question is impossible to solve. Okay, because there's a typo. I typed the question wrongly. These values are not correct. Okay, it's supposed to be 1, 4, 7, and 10. I cannot remember already. But this new question is inside the August practice questions. So I've already placed it there. So if you're interested, you can go there and look for the question. Okay, so yep. I want to go through these two because these two are the main bulk of the chapter: number patterns and algebra. Okay, so let's start with the algebra question first. Okay, thank you very much for the group of you that are still here. Okay, I hope this is has been informative so far, and I hope you are learning something. Okay, do let me know if you need me to speak slower or you got any feedback from me. Okay, then if not, I'll just carry on as per normal. Okay. Now, I'll organize these sessions a little bit earlier in the future, okay, so that I can accommodate more students. Okay, so as of right now, unfortunately, because I just ended lessons, so I needed to rush a little bit. Okay, yes, I will speak a little bit slower. Yeah, thank you. And is your name Charlene? Is it? Do you come for my session? Because your name sounds very familiar. Or I don't know. Okay, never mind. But yeah. Oh, never. Okay, sorry. Okay, never mind. Let me carry on. Okay, this is the algebra question. So 1 plus x. Okay, I'll speak a little slower. Okay, I understand I'm speaking a little fast. Okay. X squared minus x minus 6 plus 3 over 2x minus 6 minus 2 minus x over x squared plus 2x. Okay, so this is the question. Now, how do we always approach this kind of question? Now, for the group of you that are still here, this is a little trick for everyone. Number one, whenever you're facing with quadratics in the denominator, I can say this, 99% of the questions out there are factorizable. Okay, I repeat again, for quadratics that are in the denominator, 99% of these quadratics can be simplified using the box. Okay, all are factorizable. So that's what I'm going to do. Okay, I'm going to use the box to actually do it. 1 plus x divided by, okay, x minus 3, x plus 2. Okay, I'll answer a common question after I finish writing this. 2x minus 3 minus 2 plus, 2 minus x over x plus 2. Okay, so it's something like this. Okay, what's the box? The box I'm talking about is this. I call this the box. Okay, so it's the quadratic box. Yeah, it's in the shape of a box. That's why I call it a box. So sorry, I barely. Okay, but yeah, to me, I call it the box. Okay, so yeah. So whenever you're doing it like this, right? Okay, questions that I always get is that do you actually need to write the box? The answer is no. Okay, you can just use your calculator mode 33 to actually get it. Now, fun fact, within the next, messages here. Okay, sorry. So within the next 1 to 2 months, before your O-levels, of course, I will be uploading a calculator guide for everyone. So I've recorded down the 5 most common calculators that students use, and I've created a full guide as to how to hack the questions like how to use the box, how to use standard, how to get like standard form on the calculator, how to solve cubic equations, how to do all the funny little gizmo that you can do on a calculator. So I've already compiled it and I'm going to be releasing it in September before the O-levels. Okay, so you can look out for that as well. Okay, so whenever you're facing such questions, please remember, do not anyhow cross multiply throughout, because if you cross multiply anyhow, right, your values are going to be very huge. Okay, and your denominators are going to be ridiculously big. You're going to get a cubic denominator, which is incorrect. Okay, so what is my common denominator here? Okay, I hope everyone can see that this is 2x. X minus 3, x plus 2. Okay. Okay, so this is what I'm referring to. So now let's figure out what is missing. So check your denominator, this and this, there's an additional 2x. So I'll add it in, 2x plus x squared plus 3x, x plus 2 plus 2 minus x, missing a 2, and I'm missing an x minus 3. Okay, so you look something like this. Now, of course, this kind of questions, please go slow. Okay, do not go too fast and make sure that you're doing it accurately. Okay, so there is a chance that I may have screwed up, and I already did, which is here, 2x squared. So please go slow. Okay, 2x plus 2x squared plus 3x squared plus 6x minus, oh, sorry, it's a minus sign, my God. Minus, okay, where did the 3x come from? As in you talking about this one? Wait, sorry, how do you get the denominator? Okay, hang on. Okay, getting a lot of questions. Slowly. Okay, wait, let me solve the question first, then I answer. But yes, to Jolene, can you answer my question? Is the 3x the one that I put in the black arrow? Is that what you're talking about? Okay, I'll answer that in a while. 2x minus 6 minus x squared plus 3x over 2x, x minus 3, x plus 2. I'll answer your question in a while for the denominator one. Sorry, I cannot pronounce your name. So, and yeah, I need to speed up. Sorry. Okay, so 5x squared plus 8x minus 10x plus 2x squared plus 12 divided by 2x minus 3 plus 2 equals to 7x squared 2x, x minus 3, x plus 2. Okay, this is the final answer. Okay, to answer the questions, number 1, excuse me, where did this 3x come from? Okay, actually it's not 3x. The only thing that added in was this x and this x minus 2. The reason is because you compare the denominator. This denominator here is 2 times x minus 3. And my final denominator that I want is 2x, x minus 3, x plus 2. So what is missing? The x and this x plus 2. And that is the reason why this is here. Okay, so that I hope that answers your question. For Shakira, okay, I'm so sorry if I butchered your name, but yeah, I think Shakira. So for Shakira, right, how do you get the denominator? Okay, so basically what you do is that you compare every single one of the terms at the denominator, okay, and you make something common. So let's check, okay? There's an x minus 3x minus 3. So we know that there can be an x minus 3 term. There's an x plus 2. There's an x plus 2. So that will be my next component, x plus 2. Okay? Same thing, I got an x here. So that will be one of my components as well. And there's a 2 here. So this will wholly form my full denominator. 2x, x minus 3, x plus 2. Okay? So this is the final answer. Okay, yeah. Okay, great. So let me move on. Okay, so, oh my God, it's getting late. Okay, let's see, which question can I do? Okay, I would like to do the number pattern question next. Okay, actually maybe not. Okay, I'll skip the number pattern question then. Yeah, because it's pretty easy. Okay, let's jump. Yes.
Do you have any tips for number patterns?
Okay, sorry. Okay, so do you have any tips for number patterns? Okay, have. So number patterns, right? Okay, let me refer to my notes. Now, to be very fair, for number patterns, right, it's a difficult topic. So one thing I can say for number patterns is that there is this standard formula that I hope that a lot of schools actually have, which is this. Okay, so if you have never seen this formula before, Tn equals to a plus n minus 1 times d, because not all schools teaches it. Okay, this formula is really powerful because for all O-level questions, it's always this formula. Okay, so how do you use this formula? A is your first term, D is your common difference. Okay, so for the first term and the common difference, right, it will look something like this. Now, this formula can only be used when you have like common difference. So this is really important, if and only if. It really, really means that the term must have a common difference. Means that every number in between must be jumping by the same number. So I give you an example. 1, 4, 7, 10. How do I find the number pattern for this? Okay, the terms are all jumping by 3. Okay, so I'll just apply my formula, okay, which is 1, sorry, plus n minus 1 multiplied by 3. So the final answer for this is 3n minus 2. Okay, so just by doing this, right, you'll be able to identify straight away what the formula is. Okay, so this is one of the more powerful equations out there, which is this. Now, there are a few more very, very common ones, which is these few. Okay, these are some of the more important ones. Like, for example, if they ask you to sum n integers, it will look like this, and square, it will look like this. So there are some common kind of like formulas that you can memorize now. But if you ask me for tips and tricks, right, for number patterns, is to practice. So there are many questions out there that have like many types of patterns out there, but the patterns are pretty easy to see one. The most difficult to see is always this formula, and that is where you can apply this formula. Okay, so I hope that answers your question. Yeah. Okay, wait, my teacher tells me that to have to consider the term before the first term is the valid. This is valid or correct. Wow, this one very hard to answer you because this is a A-level kind of thing. So to answer your question, I wouldn't answer your question, but just do it the way that I say. You should not struggle anymore. Yeah. Okay. Okay. Let's move on then. Okay, so move on to the next chapter, which is functions and graph. Okay, the only thing I want to cover for what is the number pattern? Okay. For example, if the one that you last question which is Samantha's question. She asked for this pattern. Okay, the pattern that you chose just nice is the super easy one. So it's 1, 4, 9, 16. Obviously these are square numbers. So this is 1, 2 square, 3 square, 4 square. So what is one trick that we do, right, is that we always label down what the terms are. So for example, I call this term 1, term 2, term 3, term 4, all the way to term n. I will always look at this number here and these numbers here and do a comparison. Now, what do you notice? All your n numbers are just getting squared. So this formula is n squared. Okay. Just nice you chose the easy one. Okay, so yeah. Okay, so yeah, no worries. So let me move on, which is this, completing the square. Okay, so I know completing the square has been plaguing students for quite a while. Okay, so I want to teach you guys the simple way of doing completing the square. Okay, and that is the only thing that I'm going through for today. Okay, which is this portion here. Okay, the remaining portion of the sketching of the graph is pretty easy, so I don't want to cover that. Okay, now let's go for completing the square. So what is the question? Sorry, I forgot the question. Okay. Y equals to x squared plus 2x minus 6. Okay, so let's start completing the square first. Now, completing the square, we always need to make sure that the coefficient of x squared is 1. So coefficient is 1. That's the first condition. Okay, next thing, what do I always do? First thing I will do is the brackets, square, then I'll copy down the last number. Okay, so these are the things that I'll write down. The square brackets, the square, the last number. So you follow the sign as well, minus 6. Okay, so let's check, okay? Now, when you grab this, next thing to do is to always copy. You see an x square here, you copy the x down. You see a plus sign, you copy the plus sign down. Okay, x plus. Next thing to do, take the coefficient of x squared, divide it by 2. So this is 1. Okay, so let me write this down for everyone. Divide coefficient by 2. Okay, why? The reason is because it's in A math. So I'm not going to explain why. Okay, but yeah, just remember that it's divided by 2. Okay, so next you're going to get this term, x plus 1 squared minus 6. Next thing to do is to expand this at the corner. That's what I'm going to do now. Expand. X squared plus 2x plus 1. Okay, now after you expand this, what I'm going to do, remember that this is an equal sign. This means that both lines of the equations are exactly the same. So this means that there shouldn't be anything extra, there shouldn't be anything left out. So I'm going to compare x squared, very good. I have both x squared terms. 2x, very good. I have 2x term. Minus 6, very good. I have the minus 6. But what do you notice? There's an additional plus 1. Okay, so this is the problem. I have an additional plus 1. So if you have something extra, you need to remove it. Okay, so that's what I'm going to do now, minus 1. Okay, so what I've done here for this term here is to remove extra. Okay, and therefore the final answer is x plus 1 squared minus 7. Finish. And this is completing the square in the most simplified way possible. Okay, so you just remember the steps. Okay, so to answer your question, Natalie, in a while, I'll answer in a while. Okay, so this is the easiest way to do it. Okay, so I repeat the process one more time. Okay, first thing to do, always write down the bracket with a square, copy the last number to the very corner, leave a very huge gap here to fill up a number 4. Copy the x down, copy the sign down, the next number beside the plus or minus sign, the coefficient of x, divide by 2. Next, expand the square brackets. You're going to get x squared plus 2x plus 1. Then you start comparing what is extra or what is left behind. Okay, after that, you just add it back in or minus it back in. Okay, okay, so let me answer question by question now. So for Natalie first, now what happens when you, okay, wait, slowly. So let me answer Natalie and Dairani, is it? I'm so sorry. But yeah, I can answer your question at the same time. So you get confused when there's a negative bracket type questions for completing the square. And for Dairani's question was that what if there's a 2x in the coefficient, or there's a coefficient of x squared? Okay, so this is a common question that I always get. I give you an example. Negative 2x squared plus 4x plus 8. What you do, because I say that for completing the square, you must always force the coefficient of x squared to be positive. So what I'm going to do, factorize out negative 2. So take out negative 2. I'm going to get x squared minus 2x minus 4. Okay, and then you start completing the square for this. Just leave the -2 on the outside, don't care about it at all. Settle only the x squared minus 2x minus 4. Okay, so I hope that answers your question. Now, okay, I'm going to assume your name is Charlene. Okay, for the comparison to minus, right, is it the same as negative coefficient of x? Oh, Charlotte, I'm so sorry. Okay, but the comparison to minus, right, is it the same as the coefficient of x over 2 squared? Yes, it is. Yes, it is correct. Yes, I usually teach students that way as well, but I realized that teaching people to just identify what the number is and expanding is a lot faster. So this is to help people. Yeah, but yes, you're correct to say that it's actually just the minus of the coefficient of x over 2 whole thing squared. Okay, yes, but good job. Okay, so I hope this answers your question. Okay, and sorry for guessing your name wrongly. Okay, so do you have any tips and tricks for angle properties? I'm coming to that. Just nice. Okay, so I'm coming to that. Relax. Okay, I'm sorry if you really need to go. Okay, for those that you're waiting for the further topics, right? I'm sorry that I'm taking a bit of time. Okay, but if you are waiting for them, you can always go back to YouTube to actually look for the sections for the topics that I will give tips and tricks on. Okay, but yeah, I'm coming to angle properties. I'm so sorry that's a little bit slow. Okay, now let's move on. For inequalities and equations, I've really generally gone through just now the question in front using the angles, the algebraic expression. So I will skip over this topic. The questions are pretty simple. Refer to my solutions. Okay. Now for set language, this one also I don't really want to go through because it's a brand new topic that majority have already learned. And from what I understand from students is that a lot are very, very good at it. But one thing I want to just say, whenever you're dealing with such questions like this, will you be doing every topic tonight? Yes, I will. I'm trying my best to do every topic. Okay, unfortunately, I don't have the time to do a part 2. Yeah, I want to complete this whole session by today. Okay. Now, whenever you have questions like this, it's always good to list out every single thing. So for example, 0, 1, 2, 3, all the way to 10. Prime number, so this means like 2, 3, 5, 7, yeah, that's all. Okay, and then for perfect squares, will be 4 and 9 and 1 as well. And then factors of 36, you just fill up on your own. Okay, it is a very good tip to always remember to always expand out your brackets like this, such that you can compare very easily and don't make any mistakes. Okay. Now, let me move on. Okay, for matrices, now, these two questions are very, very easy. Okay, you should refer to the August questions that are more difficult. Okay, but in general, matrices, just remember that whenever you're dealing with matrix multiplication, make sure that the dimensions are the same. Okay, and make sure you do not screw up your dimensions lah. Okay, now usually these kind of questions will be 1 mark. If you list out everything, won't it take very long time. Now, trust me, sometimes spending the extra time is more worth it to secure that 1 mark than to rush through and not secure that 1 mark. Okay, I rather you spend the time to write out everything and make sure you get it right than you rush through the question and get it wrong. But of course, this is up to you. Okay, but this is my advice, of course. Now, of course, lah, I don't mean like if you face those kind of questions where the range is like for example, if the question is like 0 to x to 100, and then you listen to me say list out every single thing. So you sit down there and 0, 1, 2, 3, 4. No, that's not what I mean. I mean like for those that are easy to list out, you list out. Okay. Okay. Let's see. What if the x is odd with x plus 2, x is a prime number? What to do? This one you ask me privately. Okay? Because this one is a bit advanced as well. Okay, yes, so matrices, same thing, I'll just leave it, okay, because the topic is pretty simple. Okay, now I want to focus on same thing, problem in real world context. Also, problems in real world context, right, it's all about the conversions and understanding like how to pour water into the container. So if you want to see my notes for the container questions, it's pretty in-depth. Okay, so this is an example of a question where we talk about the pouring of the water. Can you go through the symbols for set notations? Can, I will in a while. Okay, so for this, if you want to see the different types of water being poured into the container, you can refer to here. Okay, so there are many different types of ways to pour water into the container, and all the graphs, all the rates and everything, I've already explained it in the earlier chapter during my rate and speed chapter. So talking about the gradient, why is it increasing gradient, why is it decreasing gradient, the explanations are already there. Okay, so this is for this chapter. This is the main bulk of this chapter, so I don't really want to talk too much about it. Okay, now to answer that question about the going through of the symbols for set notation. Now, for set notation symbols, there are mainly just three that you need to remember: union, intersection, and null. Null just means empty. Intersection means it's the joining portion, and the union is the whole thing. Okay, these are the main three that you need to know. The rest is just like subset. Subset means that it is completely inside, or this is proper subset, sorry. So it means it is completely inside the set. And I think this is about it. Yeah, or else set notation is pretty much that. So like for example, you will see union lah. This is the most common field. Okay, if you have a prime at the corner, this means complement. Okay, so let me move on. Now let me move on to the geometry chapters because those are a little bit more heavier, and I think that is where people are waiting for as well. Okay, now for angles, triangles, and polygons, now to see for properties of circles, right? Later, let me cover that. Okay, but for this chapter, okay, let me go through one of the polygon questions. Okay, so the one I want to touch is actually question, this one, this question here, the Dorman High School question. Okay, so I want to go through this because I think this question is pretty good. Okay, so let's go through. Question 1. Okay, the diagram above is made out of a square and a regular hexagon and part of a regular n-sided polygon. Given that the sides of the square, regular hexagon, and regular n-sided polygon are equal in length, and the vertex A joins to vertex C, find the values of y, n, and AB over AC. Okay, now to find y is really simple. Okay, because you're talking about an interior angle of a hexagon. Okay, so I think I'll write it. Can I just write it here? Yes, I can. Okay, I'll just write it here. Okay, no, maybe because I'm going to send this out to people, so I write it here. Okay, so this is the polygon chapter question. Okay, so for the polygon chapter question, now part A, we are looking for the interior angle of a hexagon. Okay, which is the formula n minus 2 times 180 divided by n. Okay, which is 6 minus 2 multiplied by 180 divided by 6. Final answer is 120. Okay, so this is the answer for part A. Now for part B, okay, the question is asking you for the value of n. Now, whenever you're looking for n, this is a very key tip for people. Now, sometimes when you're searching for n, it is good to actually find what is the exterior angle of a polygon or what is the interior angle of the polygon. So what I'm going to do is search for the interior angle. So interior angle is 360 degrees minus 120 minus 90, which is equals to 150 angles at the point. Okay, then after that, you know that this is a regular polygon. Later, I want to talk a little bit about regular polygons as well. Okay, so we know that this is 150 equals to n times, n minus 2 times 180 divided by n. Okay, and we solve for n. So 150n equals to 180n minus 360. 30n equals to 360 and equals to 12. Okay, so this is the solution. Now, I wanted to go through this. Now, my created notes is split up into two books. So book A is the algebra chapters. Book B is the geometry and statistics chapters. Now, unfortunately, I don't sell them separately. So if you want, you're going to get the full package one shot. And it contains example questions and everything that you need for your O-levels. Yes, it is 40 per book. Yes, no, it is 40 for both together. Yeah, so it's book A and book B. It's the same thing for my A-Math. My A-Math is also book A and book B. You'll get $40 for both. And each is like 200 over pages. So you get the luxury of like all of the content with example questions, with like explanations and everything. So it depends. No forcing or anything, just sharing with everyone. Okay. Now, the thing that I want to stress a little bit about is this. Okay, so it's this page. Okay, so just talk a little bit about it. Unfortunately, no, but we can discuss. If you message me, maybe we can discuss. Okay, now I just want to talk a little bit about regular. Okay, so for regular polygons, right? Now for regular polygons, it means that the polygon sides are the same, okay, are equal. Okay, so this means that only for regular polygons, the word regular must be there. After that, then you can split up all your angles and your sides into equal lengths. Okay, I hope that makes it very clear. The word regular must be written in the question. It cannot be just a normal type of polygon. Okay, now if you're looking for discount for the books, you need to buy other subjects as well. So like you buy more than 4, you get 10%. Okay, so just take note of that. Okay, now I just want to go through the last part because AB over AC is not an easy thing to find. So yeah, let's go through this. So how do you find AB over AC? So part C, will you be going through compound interest? I can if you want. Okay. So let's see. Now, to find this particular ratio, right, I'm actually going to use Trigo, okay, to do it, which is actually sine rule. Okay, so unfortunately, I have to use sine rule to actually find the ratio, or else this question becomes a little bit more challenging. Okay, so let me draw the diagram first. Now, whenever you're facing with ratios like this, it is always sine rule. Okay, so let me do it. ABC. Okay, so the question is asking you for AB, sorry. Okay, the question is asking you for AB over AC. Okay, so for AB over AC, right? Let's look at the ratios very carefully. AB is this line here, and AC is this line. Oh, sorry, let me just write it out properly. AB is that line there, and AC is that line there. So what I'm going to do is find what are these angles. Angles ACB. Remember that this is a regular polygon. So this is a isosceles triangle. Yes, the books are 40. Okay, so ACB, okay, is an isosceles triangle. So this one here we already calculated as 150, if I remember correctly. Yes, it is. Yes, it's 150. So angle ACB or BCA is equals to 180 minus 150 divided by 2, okay, which is equals to 15 degrees. Okay, why is it an isosceles? Because the question states that this is a regular polygon. So regular polygon means that the lengths are equal. Okay, regular means that all the sides are equal in length. That's the reason why. Okay, so this is 15 degrees. So we have one of the angles and we have AC. So we're going to use sine rule. Sine. Sorry, my pen is not working. I don't know why. Do not die on me now. Yes, very good. Sorry. Sine of angle BCA over AB equals to sine of angle ABC over AC. And just like this is the ratio that I want, okay, which is AB over AC equals to sine of angle BCA over the sine of angle ABC. Sine BCA, we have already calculated, is 15 degrees. Sine of 150 degrees. Final answer 0.518. Okay. Now, whenever you're facing, what's this? Can explanation for base of, yes, correct. It's the base of an isosceles triangle, correct. Could you zoom out to the previous solution or the solutions posted? The full like typed out solutions are posted on the Telegram channel. These are just handwritten by me lah. So sometimes my handwriting a bit atrocious. So maybe you want to look at the typed out solution, it'll be a lot cleaner. It's in the Telegram channel already. Okay. But yes, for Charlotte, right? Sorry. Then explanation for 180 minus 50 over 2. Yes, base of an isosceles triangle. So base of. Okay, yeah, I hope that's correct. Okay, so I hope that is clear. Okay. Now, just now someone asked me about compound interest, simple interest. Okay, so just to touch a little bit on that, like few seconds on it. Now, for simple interest, formula is PRT over 100. Okay, compound interest. It is P1 plus R over 100 to the power of n. Okay, so there is a difference between these formulas. Okay, remember that for simple interest, you're calculating the interest. Sorry, I spelled interest wrongly. Compound interest, you're looking for the total. This is the main difference between these two. Okay, so I repeat again. Simple interest means you're calculating interest. Compound interest means you're calculating total. Okay, now the only difference between these two I want to mention is the t value and the n value. This t value here is number of years. This n value here, number of times. So there's a difference. Okay. Okay, wait, I'll answer the question in a while. So for the number of times, right? So there's a difference. So for example, if the question states that in a year, okay, I'm charged 2 times compound interest, this means that the value of n is 2. Okay, because n is the number of times, t is the number of years. Okay, what's this? If r and t change in simple interest compared to compound interest. Sorry, I don't get your question. For Hui, sorry, I only see that name. Do you have to head down somewhere to get the books? No. I will mail it to you personally. So when you order it, right, then I'll message you to get the payment, and then after that, I'll ship the books to you. Okay, and shipping is all included as well. So you just need to pay for the book itself. The shipping is free. Okay. For R and capital R, is it the same thing? Yes, it is. Okay, R is rate, R is also rate. Okay, if the question states half yearly, then do we just times 2 to the n? Yes, the answer is yes. Okay, because it's half in a year, that's the number of times it's being charged in a year. Okay.
Yeah. But if we times the n, right, then we need to divide the r by 2, is it?
Can you repeat again, if you don't mind? Sorry. Can you repeat again? Sorry.
If they say it's compounded yearly, then if they say like 4% compounded yearly, but then like the n is in like half yearly or something like that, then the rate must divide, but then the n will times, right?
Okay, so okay, I think I know what you're trying to say. So let me check. Okay, so when the question says that the rate is compounded half yearly, right? Or when the rate is compounded, when the rate is compounded half yearly, you need to split the rate exactly in half. Because for half a year will be like, for example, if 2%, then it's 1%, 1%, that kind of thing. So you need to split it in half as well. Okay, so same for the n values. The n value need to times 2, then the rate need to divide by 2. Does that make sense?
Yeah, thank you.
Yeah, no worries. Okay. Okay. Then okay, I think I answered every question. Very good. Yes, for functions and graph and coordinate geom, I covered functions and graph already, so I'm left with coordinate geom in a while. Okay. Who's that? It's not muted. Like, please mute yourself. Thank you. Okay, never mind. Congruency, similarity. Okay. The one that I wanted to touch was. Give me a moment. Sorry, guys. Okay, yes. Very good. Okay, let me carry on. Okay, yep. Okay, the one that I wanted to cover was this question. Okay, so the line BP produces to meet AD at Q and CD to produce at R, so that the triangles ABP and CRP are similar, sorry. Okay, so whenever you're proving similar triangles, you're always looking for triple A or double A. These are the most common kind of angles to prove. Okay, so let me write out the values such that it makes things easier to see. So let me go through that question. Okay, so congruency and similarity. Okay, so let's go through this. So the first proof for part A, I'll only go through the proof. Okay, for part A. Okay, so that's the one that the majority of students will struggle a little bit at. Okay, so whenever you're facing with congruency questions, we will always draw out the triangles to make things very easy. So ABP and CRP. So let's write that out. Oops, sorry, my bad. Yeah, there you go. Sorry, give me a moment. CRP, and the last one is the baby triangle here, okay, which is PAB. Okay, so I will only be going through part A. Sorry, this was a stupid question, but what's the difference between congruency and similarity? Okay, congruency means the triangles are exactly the same. Similar means that they are similar in nature. So there is no like direct relation. There is a linear kind of relationship between the triangle, but it's very different from congruency. Okay, similar means like, for example, this triangle is similar to this triangle. Congruent means that this triangle is exactly the same as the triangle. That's the difference. Okay, so let's write it out, the values for part A. So angles APB equals to angle CPR. Okay, and very important, right? For congruency and similarity questions, it is always a good habit to write out the triangles. Okay, and to draw the triangles like this, such that you get your naming conventions correct. Okay, so vertically opposite angles. Okay, the next ones will be angles ABP equals to angle CRP. This will be alternate angle because they are parallel lines, and angles BAP equals to angles RCP, alternate angles as well. Okay, so whenever you're writing rules like this, it is always good to label what kind of rules they are. Okay, then you must write at the end by the AAA similarity test. They're similar. Okay, so some important things that I just want to explain and just take away. Do you have slides for similarity? Yes, I do. Okay. Oh, wait. Can you use slides for similarity test? Is it only when they give you the values of the side they can use the ratio? Yes, it is, but very rare you will use similar triangles that requires the sides. Very, very rare. Majority of the time is always using the angle itself. Okay, so A. These things are very important to state. Is it important to state the two lines are parallel? The question never state the two lines are parallel. Okay, because it's based on the diagram and wait, what's the reason why? Okay, so wait. Okay, got too many questions. Hang on. So hang on. Now the question did state that it is a parallel line. Yeah, because that is a parallelogram. That's to answer that question. Wait. What is DT and what is ALT? Where got DT and ALT? ALT is alternate angle. I wrote it too fast. Sorry. Okay, my bad. I thought similarity test is only AA since only two. No, AA and triple A is the same thing. Because if you prove that two angles in a triangle is the same, the last one will automatically be the same. Okay. The question didn't state. Yes. Okay. I think because the original question did state. I think I forgot to copy it now. I think that's the reason why. But yes, the lines are parallel because it is a parallelogram. Okay. So yep, this is the proof for congruency similarity. Okay. Very good. Okay, now the one that I want to go through next this one very important question, which is properties of circles. Okay, the one I want to go through is this. I'll go through the full question because this is difficult. Is there a time where you need to prove more than 3 angles? Answer is no. Okay, so because for all tests, you need to show all 3. There's only 3. Like for example, I think someone asked what are the tests, right? Congruency, SSS, ASA, SAS. For similarity, triple A, corresponding ratio plus 1 angle, 2 corresponding ratios plus 1 angle, 1 side. Yeah, these are the 3 properties for similarity and congruency. Can we just show double A? Yes, you can. Yeah, and answer the other question. Okay, now we go on to properties of circle. Okay, I want to go through this because this question was pretty difficult. Okay, so let's go through. In the diagram, TA and TB are tangents to a circle at the points A and B respectively. TBS is a straight line. The straight lines AB and QP intersect at Y. QAB equals to 27. PBT equals to PQB equals to 40. And ATB equals to 56. Calculate and state all reasons clearly the values of. Okay, let's start. PAY. Now, I received a solution that state that QA was a diameter of the circle, which is a bit weird. No, it is wrong. Yes, I'll be going through coordinate, John, but I need to give me a while. It'll be after this. Okay. So yeah, for PAY, right? Okay, so we need to find what this angle is. Now you can just see the butterfly. There's a butterfly here. Okay, so PAY is 40. Okay, so this one must take note that there is a butterfly in the question. Now for butterfly, please remember that the butterflies must touch the corners of the circle, cannot just be like floating in the middle of the circle. Okay. Now next will be angles QBP. Now for QBP, now if you observe there is a four-sided figure in this circle. 1, 2, 3, 4. So this means that this is a cyclic quadrilateral. Okay, so what is the solution for part B? Okay, so let me write it here since it's convenient. Now angles QAP equals to 27 degrees plus 40 degrees, 67. Okay, therefore angles QBP 180 degrees minus 67. Angle is, okay, wait, I'll write the reason why. Equals to 113 degrees. Okay, so this one is, yeah, okay, so this is the reason. Yep. Okay, for, wait, this is opposite angles in a cyclic chord. For part B, angle PAY, angles in the same segment. Angles in the segment. Okay. Yep. This is part B. Part C. Now, angle TAP. Okay, so TAP need to be a bit more careful. Okay, so how do you do TAP? Now let's see. TAP. Now, first thing, because right, TA and TB are tangents, so these two lengths are equal. Okay, so that's the first thing to remember because they're extending towards a certain point, so therefore those is equal. Angle ABT will equals to BAT. So this is an isosceles triangle. Okay, so we can actually find what is the full angle there of angles BAT, which is 180 degrees minus 56 divided by 2, which is 62. Excuse me. Angles in an isosceles triangle. Okay. Wait, I'll answer questions in a while. So angle TAP equals to 62 degrees minus 40 degrees. Okay, which is 22. Okay. Just to answer some questions first. Is there a use for exterior angles equals to sum? Yes, there is. But you must use the scenario correctly. Okay, for your question. Can you use angles in opposite segments if the four-sided figure covers less than half of the circle? Yes, the answer is can. Okay, because the property for angles in opposite segment is just that the four vertices must touch the circumference of the circle. Okay. Part D. The question is asking you for AYP. Okay, so let's do that. So you're looking for this. Okay, so AYP, how do I find that? Okay, so now we have found that, okay, we can first find what is angles QAB or QBA, sorry. We can find what is this angle first. So angles QBA is equals to 113 degrees minus my answer for part C is 23. No, is 22. Yeah. It should be 22, not 23. Unless I calculate wrongly. Oh yes, I calculate wrongly. 56 divided by 2 is 63. Oh dear, I'm so sorry. Thanks. Yeah, let me just double check. Oh, 62, correct. This is 22. Yeah, it's 22. Okay, I use 90 minus 40. Okay, wait, I'll get back to you in a while. You're finding which angle? TAP. How do you get 90? You cannot use 90 because 90 minus 40. You do not know that BA is a diameter of the circle, so you cannot use 90. So that's wrong. Yeah. Okay. So QBA equals to 113 minus 62 minus 44, minus 40, sorry, which is equals to 91. Okay, next you can find what is angles QYB, okay, which is equals to 180 degrees minus 40 minus 91, which is equals to 49 angles in a triangle. Last one, therefore, angles AYP equals to 49, vertically opposite. Okay, so this is that. Last one for part E is to find ACQ. Okay, so ACQ is, okay, same thing. You have a four-sided figure in the circle, like that, like that, like that, like that. Okay, so four-sided figure in a circle, we can settle that. So angles, ACQ equals to 180 degrees minus angles QBA, which is equals to 89. Opposite angles in a cyclic chord. Okay, and this is the full solution for this question. Okay, so for circle properties, right, in order to score for circle property question, you need to practice a lot, okay, and you need to open up your eyes a little bit more to see all the different types of figures. Okay, sorry, I know you have a lot of contents to go through, but what time are you ending? I actually do plan to end by 11:30, but I have a few more chapters. So this video will actually be uploaded onto YouTube. So if let's say you want to skip ahead to the other chapters, you can actually go there and look at it. Okay, so you're feel free to leave anytime you want, because I understand it's a bit late already. Yeah. Okay, I do have a little bit more chapters to go through, so I'll just go through first, but then all the questions I'll just continue and I'll upload it on YouTube as well. Okay, so yeah, no worries, no worries. Okay, so you can just leave if it's too late for you already. Okay, what other chapters are you covering? Okay, so the last thing I actually want to cover is Trigo. Okay, wait, I want to cover Trigo, and the last one would be the coordinate jump. These are the last two that I'm actually covering. The rest I will not be covering anymore. Okay, because I don't have the time. Okay, because the remaining chapters are pretty simple. Okay, so I'll do Trigo, and last one will be coordinate jump. Okay, I'll choose one of the questions here for Trigo, and then I'll go through. Now, I know the alternate segment in AM, but can you use it in circle properties? Yes, you can. Okay, that one totally fine. Okay, two more questions and then we'll end for today. Thank you very much for staying. Okay, same thing lah. You feel free to leave whenever you want. The questions will be uploaded onto YouTube as well. Okay, so in case anyone wants me to go through, yeah, you can just go there to take a look at it. Okay, good night for those that are leaving. Okay, now the question that I wanted to go through was actually this. Okay, the CGS question. Okay, same thing. All solutions have already been provided online. So if you need the solutions, you can actually just go there to take a look at them. Okay. Now, let's go through this first. Then last one will be the coordinate jump, and then I'll end today. Okay. Now the figure shows triangle ABC with AC, BC equals to A, and AC equals to B, and AB equals to the root of A squared minus AB plus B squared. Find the angles of ACB. Okay, so how will you do this? You'll use cosine rule. Okay, so for part A is cosine rule. Let me write it out here. Now for cosine rule, make sure that you use it properly. Okay, I will always write it in terms of the letters. AB squared equals to AC squared plus CB squared minus 2 times AC times CB, the cosine of angles ACB. Okay, so this is for that. Now we simplify into cosine of angle ACB. Okay, now we can write out all the values. The root of A squared minus AB plus B squared minus B squared minus A squared divided by -2 of B times A. Okay, now once you simplify this, you will actually realize that this is actually half. Okay, so angles of ACB equals to 60 degrees. It's that simple. This is a very easy question. Okay, now the reason why this might be a little bit more difficult is because if your manipulation is not strong, okay, and you screw up your cosine rule. Okay, just remember that for cosine rule, a very important tip is to always write out in terms of the length. Okay, now the last one I want to write, if given the AC is 2 times of BC, why is it half? What thing half? Oh, you simplify lor. Okay, let me simplify for you. Half. You're left with half. You see, all the things will cancel. Everything will cancel and left the 2. So that's why the answer is half. Okay, so angles of ACB equals to 60 degrees. Cosine inverse of half is 60. Okay. Now for part B, this is sine rule. Okay, so just remember for sine rule. Now the question states that AC is 2 times of BC. Okay, so we can write down that AC equals to 2A. Now we have AB's length, so let's simplify them. Okay, A square minus AB plus B square. Okay, A square minus A, times 2A plus 2A square equals to the root of 3 times A. So now I shall do sine rule. Okay, sine of angles ACB over AB equals to sine of angles, my bad, BAC divided by BC. Okay, and then you just simplify. Okay, so sine of angle BAC equals to A sine 60 divided by root 3 over A. Root 3 over A. Sine 60 is root 3 over 2. Okay, the A's will cancel off. So root 3 over 2 divided by root 3. Okay, which is half. Therefore, angle BAC is 30 degrees. Okay, and this is the full solution. Now, for this question, the reason I chose it is because now the manipulation is very important. So sometimes when manipulation gets a bit complicated, that's why students start to struggle, but always go slow. Okay, and always make sure that you know what you're doing. Okay, always take it step by step. Okay, EMS students do learn that sine 60 is root 3 over 2. It is, they do learn because they do need to memorize the standard angles. So brother, yes, they do. Okay. Now, this is for Trigo. Okay, and for those that are staying for Trigo, yep, there you go. When he makes more sense than your tuition teacher. Yes, of course. That's why look for me if you need help. Okay, so no, just kidding. Okay, so yeah, if you need any more help, you can just look for me. Okay, so last one, if you want to stay, I'm just going through one last question, which is for Trigo, which is for coordinate job. Okay, and I promise you for coordinate job, maybe I'll be able to help you as well. Okay, in EMF it's taught, but EMF it is because the students do know that there are special angles. Trust me, it is. Okay. Okay, for coordinate job, the question that I wanted to go through is this one. Okay, this CGSS question. Okay, this is the very last question I'll be going through. Now, I did say that I wanted to go through like every topic, but unfortunately, I didn't have the time. So I'll plan for more time in the future. Okay, but as of right now for today, I think this is good enough for everyone. So that's why I think this is the best that I can do for now. Okay, if anyone needs more help for the remaining questions, because I know this topic is tough, that's why I want to focus on it. Okay, so for coordinate job, okay, if you're still here for coordinate job, let me share with you a little bit of my notes for coordinate job and some of the things to take note of for coordinate job. Okay, so I just run through you my notes super quick. Okay, so number one, whenever you're looking for the equation of a straight line, it is always y equals to mx plus c. Okay, now some important things, right? It's like the midpoint of a line, the distance of a line. These are some of the things that you need to remember and some of the conditions. So number one, if two lines are parallel, it means that the gradients are the same. Okay, if you have 3 points on the same line, how do you test? You test for same gradient. Okay, now if let's say you have like vertical lines or horizontal lines, remember that for vertical lines, the x coordinates is the same throughout. Horizontal lines, the y coordinates is the same throughout. Okay, now for this one, this is the last one I want to say. Coordinates of x and y axis. Remember, whenever the question says that the graph cuts the x-axis or y-axis, x-axis means that y equals to 0, y-axis means that x equals to 0. Okay. Yeah, I wanted to go through graph sketching as well, but the problem is that I'm online, so it's a little bit more difficult for me to actually sketch the graph and go through stuff. So I'm sorry, but I can't. But if you got any questions on graph sketching, you can still ask me right now during the session. I can answer you as much as I can. Okay, so I'll leave the last segment for like Q&A for any topic that you want. But these are the main questions that my goals are to finish. Okay. So let me finish this question first. So if you have any questions for other topics, I'll be here until the last person leaves. Okay, so just let me know. Okay, now let's go with this question and then we will end for today. Okay. Yeah. Okay, so the graphs, the triangles with vertices P, Q, and R are shown in the diagram. You need to find the equation of the line PR. Now, whenever you're looking for the line PR, okay, whenever you're looking for a line, this is the thing that I always write down. 1 gradient, 1 point. Okay, you will always need 1 gradient and 1 point in order to find the equation of a line. So let's first find this gradient. Okay, so the gradient of the line PR, okay, is 3 minus -5 over -5 minus 5. Okay, and this is -4 over 5. Next, we have the equation y equals to -4 over 5 plus c. Okay, so what we do now is we substitute any of the random points in 5, -5. Okay, and we're going to get this -5 equals to -4 over 5 multiplied by 5 plus c equals to -1. Okay, so therefore the equation is y equals to -4 over 5x minus 1. Okay, this is the equation of the line. Now, students will always struggle to remember how to find things, But for coordinate geometry, it's one of those chapters where it's very algorithmic based. You just need to memorize the step-by-step process and you will get it right. Okay, so for example, if you're looking for an equation of a line, just memorize that you're looking for 1 gradient, 1 point, and that is all you need. Okay, next one, the triangle PQR. Now, I will always get this common question whenever I go through a question like this. If you take A math, can you use shoelace? Can you use the y minus y1 equals to mx minus x1 equation? The answer is no. Okay, try not to do it because A math students only learn those formulas, and everyone learns the E math methods. So use the E math methods to solve the questions. Never ever use the A math way. Okay. Now for the area of triangle PQR, now this is an obtuse triangle. So remember, whenever you are finding the area of this kind of triangles, it is this height multiplied by this length. Okay, so this is pretty simple. This is 4. Okay, and this whole height here is 8. Okay, so the answer is just half times 4 times 8, which is 16. Now, if you're curious as to how I managed to read the coordinates out, look at this. Whenever you're reading on a horizontal line, look at the x coordinates. Whenever you're looking at the y and you're looking at a height, look at the y coordinates. So this is from 3 to -5, which is 8. X coordinates 1 to 5, so it's 4. Okay, this is how to remember. Now the perpendicular distance from the line Q to the line PR. Now this method here is a very famous method that we all use, is to equate the two ways of calculating the area of a triangle. So let me show you guys from my notes. Excuse me, this one here. How do you find the shortest distance to the perpendicular distance from a point to a line? What we always do is to always equate the two different ways of calculating the area of a triangle and use the half times base times perpendicular distance method to calculate this shortest distance. It's a very famous method. And this method is always in conjunction with questions that ask you to find the area of a triangle. So every time the question, right, I'm pretty sure it's like that one. It's designed in this way. One of the parts will ask you to find the area of a triangle. The next part will ask you to find the perpendicular distance. And that is the fastest way to solve the question. So what I'm going to do right here, okay, because we know that this is the perpendicular distance, okay, the first thing to do is to actually figure out what is the length of PR. Okay, so I'm going to do that here. So PR is equals to what length? Okay, so it's equals to the square root of -5 minus 5 square plus 3 minus -5 square. Okay, and this is actually the root of 164. Okay, so what's the area? We know that it is 16 equals to half times the perpendicular distance multiplied by the root of 164. Therefore, the perpendicular distance is 2.5. Okay, 0 units squared. Okay, so this is a very common method. I can use Takaso also for the shortest distance. Yes, you can. Okay, but the problem is that you don't have an angle here. So you want to use Takaso also can, but you need to find law. So this is faster if you use this method. Okay, Takaso works for trigo questions. For this kind of coordinate jump questions that need perpendicular distance, this method is faster. Yeah, trust me on this. Okay, yeah. Next one, the coordinates of the two possible distances of S. Okay, this one very easy as well. So let me remove the diagram a bit. Okay, this one I throw here. Sorry if I'm like writing all over the place. I'm so sorry about that. Okay, but for part D, the question is asking you for the two possible locations of S such that the 4 points PQRS are on the 4 vertices of a parallelogram. What is the definition of a parallelogram? A parallelogram means that the lengths, opposite lengths are equal. So if we know that this is length 4, this means that your S can either be this way 4 or this way 4. So what's the coordinate? Okay, so -1, 3, you plus 4 to the 5, or you minus away, -9, 3. These are the two answers. Okay, because you know that it is a parallelogram, so those two lengths must be equal. Logic. Okay, last one, the value of tangent of angle PQR. Okay, we are looking for this value here. Okay, so remember that for tangent, right? Okay, I know this is not really tested in the syllabus for obtuse angles for tangent, but you must remember that for tangent, right? Okay, whenever you're looking at an obtuse angle. Hi, sorry, please mute yourself, whoever you are. Thank you. Yeah, okay, so tangent of an obtuse angle, right, is the negative of the angle. Okay, just remember that it is negative. For those that take AMF, you will know the reason why this is negative. Okay, but for those that do not take AMF, just remember that tangent is also negative. Sine is positive, cosine is negative, tangent is negative. Okay, to answer your two questions, I answer in a while. Let me solve the question first. Okay, then those that want to go can leave already. Okay, so how to solve this question? We are looking for PQT. So what I'm going to do is that I'm going to draw the triangle down and find out the lengths. This is 8 and this is as well 4. So what is the ratio? It's just negative of, sorry, it's not 4, it's 6, my bad. Okay, so it's just -8/6. It's -4/3. Solve. Okay, I'm done. Okay, these are all the answers for the questions that I wanted to go through. If there are any other questions that I want to go through, I will record myself doing the questions and then I'll upload onto YouTube as well. Okay, all questions can be found on Overmark's YouTube channel. Okay, so you can look from there. Okay, I will answer questions in a while. Let me just say a few more things before we end for the remaining people that are still here. So I've been referencing my notes and my crash courses and everything. So this is for me to promote the other subjects as well and as with my subjects as well. So all the notes are actually curated by tutors like myself that we do know our background and we do know like what we are here to deliver as to what we have promised. Okay, so the notes are designed in the way for my subject. The notes are designed in the way to help students as much as possible provide as many example questions as possible, and also to give you guys examples and like tips and tricks for all the questions, common examples and everything. Okay, so if you're interested, you can look for the curated notes on the Overmark website. Okay, and the last thing is that for the crash courses, so each of the subjects actually do have crash courses going on. Okay, so I just ended my EMath crash course a few days ago. I'll have one more session in September and October. Okay, and I have my AMath crash course in 2 weeks' time. So for those that are interested in the crash course, the notes will come free with the course. Okay, so you just need to pay for the fee for the course. And then after that, you'll get the notes and you get the full 4-hour session with the tutor. And then they will explain to you, they will settle in their own lessons. For me, I will be personally going through every single page of the notes and explaining to you why I write certain things in certain ways. Okay, so that is for myself. Okay, if not, I'm so sorry that I extended past my time that I said 1 hour, 1.5 hours. But thank you very much for your attention. For those that are watching on YouTube, I do wish you guys all the best in your studies. If I were to organize another session like this in the future, I will do it in an earlier time and I'll cover more questions if possible. Okay, thank you very much for your attention. And yeah, I will stop the recording here. So thank you very much. See you guys next time. Bye-bye. How to stop recording.